Hello, Algebra A and B. This is looking to be, I believe this is most likely your last lesson video from me, because I think it's going to be a last assignment I'll be giving out to you all. That way you guys have time to catch up and finish up before the end. So this week's assignment I sent out was to scatter plots. So this was actually the last thing we were getting to before the end of when we were in class together. So we were working with our statistics unit. So we're going to take a look at some information on scatter plots. So for Algebra A, some of the terms I use here might be new to you, so don't freak out about that. You're going to be looking at those more next year in Algebra B. And for those students who are in Algebra B, all the terms I use today should be familiar to you, hopefully. All right, so let's go ahead and take a look at the first section. It says, state if there appears to be a positive correlation, negative correlation, or no correlation. When there is a correlation, identify the relationship as linear, quadratic, or exponential. So the goal here is to look at these scatter plots that have been created and decide if you think it matches or looks similar to one of the graphs that you've looked at previously. You guys should know what a linear equation graph looks like. It should look like a straight line. And for a quadratic, for the Algebra A kids, since you haven't seen this a whole lot yet, that's when we're looking at a U shape. Now it can be going like this, opening like a normal U, or it can be upside down. Both we would consider a quadratic shape. So you guys have been introduced to those, but you haven't worked with them much. So this would be quadratic if it has a curve. The biggest way to identify is if it's curved and it looks like it would then curve back. And then you have an exponential. So for exponentials, that is when the numbers increase drastically, super fast. So it could start really low, but then it's going to skyrocket and just keep going. It doesn't ever come back down. It would just continue increasing exponentially. It's where the term comes from. But it could also decrease exponentially. So it could start really high and then go really low like this. So it's basically the opposite. It's not like a parabola. It doesn't go up both sides. It's just, think of it as almost like half a parabola. Think of it as half of your quadratic. Okay, so with those shapes in mind, I'm going to take a look here at our first four and walk through them with you. I'll take you through the steps that I use to determine. So as I look here at number one, so the first thing I'm supposed to do is identify if I think it has positive correlation, negative correlation, or no correlation. So I'm looking for patterns. Do I see any kind of pattern? Do I see any kind of line forming? Do I see a quadratic? Do I see a parabola forming? Or do I see some kind of exponential pattern? And on this one, on number one, it's just scattered. I don't see anything. So I would say there's no correlation here. See how all of the points are scattered? There's no way I could try to draw any kind of graph that we are familiar with through this. So no correlation is the verdict for number one. So remember, the term correlation is we're referring to how related it appears to be. I'm going to put no CORR for correlation, abbreviated. All right, so now let's take a look at number two. We'll go through the same steps. First, we'll see if we can identify some kind of correlation, whether we think it's trending upward, downward, or no correlation, like number one. But as I look at number two, I see that all of the data appears to be trending downward. It starts high and then it ends lower, and it's all trending the same direction. When you have a pattern where you see things are trending, that is how I know there's some kind of correlation, but we need to decide if this is positive or negative. So just like a slope of a line, we will determine it the same way. If I am decreasing or declining from left to right, that is negative. If I am going upward and at an incline from left to right, then it would be positive. So this would be a negative correlation. I'm going to put NEG for negative. And again, CORR for correlation. So I have negative correlation here. So since I do have a pattern this time, I need to decide what kind of relationship it is. So I know it's negative correlation. Now, do I think it's linear, quadratic, or exponential? I've kind of already given this away to you because I was able to draw a line through that cuts through most of the points. If this is the case, if you can draw a straight line that cuts through most of the points, then I would call this linear. There's no kind of curve. It's all trending the same way. So I would call this linear. I'm going to go ahead and write out linear. This one's a shorter word. Okay, so that's it for number 2. You have decided what kind of correlation it has and what type of relationship it shows. All right, let's look at number 3. So let's look at this one. Well, it appears to be trending upward, but I see a curve. You guys see this? As it's going, when it gets up toward about 0.8, it starts to curve. So I see a curve going on, but then it trends back down just a hair. So I can see that this is beginning to take the horseshoe type shape, the U shape we were looking at, that parabola. So first, I'm going to say this is positive because it is trending upward, because it starts low and then it ends higher. So I'm going to write POS for positive. CORR for correlation. And then the name of the relationship is quadratic. Quadratic is how we would identify that type of relationship. When you see the curve, the U, the horseshoe, however you like to describe it in your mind. So I'm just going to put quad for quadratic. Okay, let's take a look at number 4. So this one's interesting. It starts up very, very high. That right up here. And then it begins to curve downward, but then it bottoms out and flattens out. So this is how I would describe an exponential relationship, because it changes very drastically and quickly, but then it bottoms out and flattens out. A quadratic does not flatten out for an extended period of time, depending on the equation. So I would say this one is an exponential. But I also need to decide what type of correlation it is. It starts high and it ends lower, so it's trending in a negative direction. So I would say this is negative correlation. It's in the right. And then once again, we identify the relationship as exponential. Right, EXP for exponential. So hopefully from this you can see the difference between them. So if there's no pattern, if they're just scattered everywhere, it's no correlation. In number 2, we have a linear relationship because it's all trending the same way and there's no curve. But it was negative because it was decreasing from top to bottom. Sorry. Again, on number 3, we had a positive correlation because it is trending upwards from left to right. And then we called it quadratic because it has a curve to it, and then we can see it just barely starts to come back. And then on number 4, we called it exponential because of the shape that it was starting to take, and then negative because it's decreasing from left to right, or as x increases. All right, so that is all for the top section. Now let's discuss the bottom section. So on the bottom, you are making your own scatter plots. So it gives you a table, and it gives you points to use. And after you create your scatter plot, then you want to go through the same process we did up top. You want to say whether you think it has positive, negative, or no correlation. And then you want to say whether you think it is linear, quadratic, or exponential. I'm going to plot a point for you as an example here to make sure you're understanding how to read the table. So my x value is 1,000. Remember that our x value goes on our bottom axis here, the horizontal, and then our y values, that's going to go on our vertical axis here. So 1,000. So if I'm looking at my scale, on the x's of our first, it appears to increase by 1,000 at a time. And then on our y values, it is increasing by 500 at a time. So it looks like we're going to have to do a little bit of estimating, but not too bad. On our x's, it's all even points, it looks like. So 1,000 would be right here, our first unit on the x, and then I'm supposed to go up 1,300. So that's going to be about halfway between 1,000 and 1,500. So there would be my first point. Now, let's look at a second point here just to make sure you see. And then I have a point at 2,000 on the x and then 1,500. So that would be 2,000 here, and then it'd be up just slightly higher than our last one, right on the intersection. So you guys would go through and plot all of these and then make your decisions on what type of correlation and what type of relationship you think you see. If you guys have any questions, feel free to email me and ask me. I'm available pretty much anytime, so just let me know what you need. All right, you guys have a good rest of your week, and hopefully I'll see some of you guys on Friday for Zoom.